and welcome now to the automotive session. And I think I need to start with explaining why we are doing this together. So both BMW and Nokia are part of 5G Automotive Association, which is an association which was founded in 2016. And the intention was to bring telecoms industry and automotive together. And by the way, BMW and Audi, two Bavarian companies, are founding members, 2 of 8, as is Nokia, for instance. And the NTN topic is one of the hottest topics at the moment in 5G Automotive Association. That is really visible. There is a tremendous interest. Not everybody is really contributing, but nearly everybody is monitoring what's going on there. And that's why we decided to do this also together. And Olaf will then join for the second part to give even more automotive specifics. And I want to start with some scene setting on this. And I picked a map from the Federal Communications Commission in the US showing network coverage. And I picked an area which many people know, the park. And if you look at the map, you can see on the right-hand side the different, or the main network operators, AT&T, T-Mobile, and Verizon, with different colors. And the yellow is non-covered part. And you can even see one or the other section of the roads is not covered. And that's obviously an issue for the automotive industry. Summarizing the picture, looks like that. Today, vehicles, basically all new vehicles, are connected, typically with a preferred network operator. The picture shows 2 different network operators. Obviously, one car manufacturer picks one, the other one the other one. And that's the way how the country or the area is covered. And you see there's still a part which is not covered for the vehicles, which is the problem. Now we see different measures, and you see 3 here, to increase the coverage. What's happening around the world? The first one is a feature which is being deployed today by many OEMs in many regions, national roaming. That's something you don't know from your smartphone, because smartphones typically are not allowed to do national roaming. But for the automotive industry, the network operators have agreed to provide that capabilities, which means if a vehicle in this part, the blue one, for instance, moves into the green area and green only area, it will still get connectivity from the other operator. The other measure, which in particular in Europe has been applied by the regulators, is the second one listed there: road coverage obligations attached to the 5G licenses. And we will go into a few more details in a minute. And last but not least, the third measure, in particular in Europe, we see that a lot of national, regional, and even European funding goes into the network operators to cover some of the white spots which are known. Different mechanisms in place, also in Bavaria, some specifics. So that's also one measure to increase the coverage for the networks. Now let's look into the second point, road coverage obligations. The slide shows 4 examples how the regulators in those countries try to address coverage issues with 5G networks. Good example, Germany. At the top, fairly heavy obligations related also to transport, to roads and transport in general. So it means railways as well as waterways. I don't think they have met their obligations to 100%, but it is good that the regulator, they received a lot of pressure before they did the auction to put those obligations in place, that they really set the scene with such tough applications. By the way, if we look in Europe, Greece has fairly similar obligations like in Germany. Second one, Slovenia. You can see already a difference. Motorways, same thing, but other roads, it's already less and not so tough like in Germany. If you go further, Czech Republic, they even focus only on the transport, the European transport corridors. Yeah, which means other roads are not important from the regulator's point of view. So they expect that the business solves that problem. But as we know, they will not solve all the problems. And it's not just Europe. Another example here at the bottom, for those in the back, maybe you may not see it, the auction in Brazil in 2021, they just said telecoms must cover all federal highways. So that's definitely a country where the topic of today is going to be interesting as well, like other big countries. So that's one way of addressing it. But we know, let me jump back. Yeah, we know that we will not address with 5G networks this part. So the non-terrestrial networks will have to play a role in covering nearly all parts of the world. There are still a few issues with tunnels, etc. But the big question for the industry, for the automotive industry, and I guess also for the satellite providers, how big is this part? That has an impact on the business case. And to be honest, we don't really know. Lots of activities. You saw the picture at the beginning from Yellowstone National Park. My colleagues in Nokia, they did some calculations based on that web page, and they calculated something like 8% of mainland US not covered. Something 8%. Alaska, obviously the number's much bigger. Yeah. But this is based on a web page and the data from the FCC. Colleagues from Rode and Schwarz, they talked about some other numbers, and they quoted also some US sources. Let me repeat some of those quotes. They say 57 million hikers have no guarantee to get connectivity when they are in the mountains or somewhere else, or 11 million hunters, and what is even more important, another number, 14,000 national and state park rangers. They have no guarantee that they have coverage everywhere. And as you know, their job is to help if necessary. Yeah. So in 5GEA, we started a project to get better numbers. And we received some first input. We used an external company for that, and the first input we received was not really 100% satisfying, I have to say, reflecting that this is a real challenge for everybody to get those numbers. How big is this section here? Okay, work to be done. Now let's look into the technology. If I jump back, obviously we have a clear focus that everything needs to be covered by a 3GPP standard, and Olaf will mention that why this is so important also for the automotive industry, knowing that we have some proprietary solutions as well. A quick view onto the roadmap of 3GPP, and we can see that there's quite some work to be done. We see with release 18 a lightweight integration of the mobile networks and the non-terrestrial network, and release 18 is something like end of 2023. Then there is some other parts, typically following a basic standard with detailed specifications. So this will take time. We have some time. At the same time, obviously there is a need for the automotive industry to improve their services, which Olaf will cover. Let me finish with 2 slides. One is AST Space Mobile. Why is it so interesting? First of all, Nokia is involved in this. But the second and more important thing is, from the beginning, these guys put as a clear objective, they want to use a standard mobile phone to provide connectivity. And that is obviously something where you could say, okay, if a smartphone is connected, then the vehicle can also be connected. Yeah. Also, there are lots of challenges to be addressed. That's why also the roadmap of 3GPP shows a step-by-step approach. But there's a second element: strong collaboration with mobile network operators. These guys take that seriously. If you go onto their webpage, then you see how many of those big operators have already aligned or lined up, if you like. And it gives you also an impression where they want to start their services. We are talking about Africa, we are talking about Middle East, parts of Asia, and if you look at the partner operators, you find most of the big names there. And that shows also a commitment. The last one is what we do as Nokia. I skipped that. We are providing some equipment, and it's public. And that's, I think, what I want to close with. Now, Olaf will take you to more specific, why is it so important for automotive?
Yeah, hello everybody. My name is Olaf Eckart. I'm from BMW, and as Uwe already mentioned, we work closely together with Nokia, especially via the Automotive Association 5GAA. And I think it's worth mentioning that I think my colleague Oliver Wick, who is also here in the room, was also already like 1 year ago here in this one of the previous events talking about the such non-terrestrial network topics. So, and BMW has started already like in 2019 to look into this topic, but really more intensive discussions started like last year. And for instance, last year in June there was a conference in Berlin organized by the ESA, where also BMW appeared the first time, like in the a wider public, telling that we are looking to this topic. And the question which is really always asked first to us was, why is it so important to us, and why is it now? This is like the first thing we want to explain. And the first point is, and I'm already, Mr. Scalise already said it, we have the same excuse as the train riders have. We always say, sorry, I'm sitting in a car. So this is very similar to what some train riders experience. There are gaps in the networks, and we are looking to ways how to close these gaps. And then we also are very much aware that our business models are getting disrupted right now by new digital services. So the way how we have earned money in the past is not the way how we earn money in the future. So, for instance, in the past, BMW was perceived very much for its powertrain, for its design, for its the way how it is driven. This will also be important in the future. But what is also becoming more and more important is also what kind of digital services are we offering. And this is really the key of the discussion. For instance, if you look to the last motor show in Shanghai, you can see that our competitors in Asia are focusing very much on the digital services, and you can see it in the cars. Now you have large screens, you have all kinds of services, and the consumers are adapted to this, and this is very important. So this is, I can only say this is really key to survive in the future. And then there is another fact, and this is also which we have recognized, that the new space approaches are also disrupting the aerospace industry. So basically, we see, for instance, by the activities of Elon Musk, that the costs to launch satellites are going down considerably. You can do things now which have not been imagined 10 years ago. So now it's possible to launch large satellite constellations in the low Earth orbit, and things are possible now which we were not able to think about some years ago. And then there is also one of the activities which we have recognized, that's basically the 3GPP standardization. And we just see that the non-terrestrial networks and the terrestrial networks are already on the way to being integrated. So therefore, it is one thing. This is a train which is running and where we also want to jump on. And I will also explain it later on, that it is not enough just to watch what is happening. It's important to influence what's happening. And that's also one of the things we have learned in the meantime. Last year, we only have spoken about our requirements. But this year, 1 year later, I can also explain that we are already active in shaping this future. And we are also very much aware that we as a single car manufacturer cannot influence something on our own, but if we find collaboration with other companies, especially with automotive and telecom, we will be able to do that. How is this moving? Yes. One picture which we have prepared also for our internal discussion, but also for the discussion in the public, is that we are very much aware about the chances, but also about the challenges which we have, which are offered by non-terrestrial networks. On the one hand, the low Earth orbit has the advantage that we have much lower latency. It's below 30 milliseconds, which is, from our point of view, for many applications, not a burden. We can do a lot of things without too much problems caused by latency. On the other hand, we see that today's constellations, they have like a spot beam, which is quite large, and all the customers on the ground, all cars or all handheld, all cell phones, share the data rate which is transmitted from the satellite. So basically, we are very much aware that broadband applications will be very difficult to provide. So the more customers are in this area which is covered, the less capacity we can distribute to one single car. So meaning for us, this whole non-terrestrial network topic is an extension to terrestrial networks. We know that we have to rely on the terrestrial networks in most cases, but NTN is for us a very good extension of that. We are able to extend the coverage. This is for us something where we get connectivity in areas where we don't have terrestrial connectivity. One of the discussions we have right now is, for instance, do we cover all the small coverage gaps which we experience in our daily life? And one of the things we have learned, we cannot just close all the small gaps which we experience today in Middle Europe or something like that. So for us, this whole topic is probably something which is more interesting in other parts of the world where we have low or no coverage by terrestrial networks. And this is something what we have learned in the meantime, that this is not the solution for everything. But what is the most important message out of this picture is that the networking, the interaction between non-terrestrial networks and terrestrial networks, this is key. So for what we call as ubiquitous connectivity, we know that both networks have to be interoperable, and all the roaming and the handover procedures, all this can only happen if the non-terrestrial networks are based on mobile global standards. And this was also the reason why we have been active in the 5GAA in the last year. And I can also tell some things we're doing right now. For instance, right now the so-called release 19 within 3GPP is collecting the topics which have to be considered for this release. And we just did it in the last weeks, that we have collected the requirements from the automotive industry in the last weeks, and we have prepared one high-level one-pager where we have described what requirements we have, and we are defining the so-called UE characteristics for two new additional antenna types. One is a patch antenna for the SNL band, and one is a phased array antenna for the antenna for the frequencies above 10 gigahertz, because we are very much aware, in order to get this integration done, everyone has to have the same assumptions, and the whole network has to be built on some key cornerstones. And therefore, what we are trying to do now is really to specify the characteristics for these two new antenna types, so that everyone can then have the same simulation assumptions and can develop the chips, the equipment, and everything else in order to make this happen. And therefore, this is something what is happening right now. And we are also preparing a so-called white paper where we are collecting all the necessary requirements which are important from automotive and from a telecommunication perspective. And this is something where we are basically in. And I personally lead this work item within the 5GAA, and I can agree with Uwe. This is really one of the most interesting topics right now within the 5GAA. So coming to the automotive applications, and this picture has not much changed compared to last year. We basically distinguish between applications which just require a so-called narrow band data rate, which what we perceive as everything below 400 kilobits per second. With this narrow band data rate, we would be able to support all kinds of telephony applications, also the so-called e-call, emergency call, all kinds of road safety applications, and also so-called remote services. As you might know, most of them, the modern cars, have all kinds of functions which you can control from remote, or where you can basically see in what condition your car is. And we know that our cars are communicating permanently with the cloud in order to work properly. So this is the first group of applications. Then the so-called wideband data rate applications. These are applications which are mostly necessary in order to manage our fleets and to have some diagnostic functions and to enable the proper functioning, for instance, of electric vehicles. And then, and this is something where we believe now that this is something which will happen not in the near future, but it will take some more years, are the so-called broadband data rate applications. And these are the applications like video on demand or gaming. And there we are talking about data rates above 10 megahertz per second, which are which really require a high data throughput. The pictures you see are from one of our current cars, and for instance, the theater screen on the right-hand side is already, for instance, in the 7 series integrated as an extra feature, but this service must rely today on the terrestrial reception. So, but you can see most of these applications are already available, and this is also a lesson from our side. We have not identified any new non-terrestrial network use cases. We basically support the already existing terrestrial use cases which are already described and which we already experience today. And basically we want to extend the coverage and want to have a better user experience. Yeah, and finally, this is also something which is very important to talk about. Like 1 year ago, everyone was really euphoric about this whole topic. But today, after 1 year talking and being involved in a lot of discussions, we are also very much aware of about the challenges we have in front of us. And for instance, we are not in the comfortable situation as the trains are, just from the space we have for antennas, or from the energy which is available to have like the powerful antennas. So we have a lot of restrictions from the space and also from the energy consumption. And therefore, in order to make this happen and in order that this can take place, we have to deal with all these questions here. And therefore, we can really summarize, we have these 2 key questions which have to be solved. On the one hand, are really the technology constraints, which I just want to have listed here, but we could have talks for hours in order to go into the details, and also from the time. So all these things will, from our point of view, take years until this will evolve. And the question is really, when are really non-terrestrial networks available? And this is especially in the background for that Europe is talking about IRIS². We are really interested in getting answers when IRIS², for instance, can deliver a potential solution for us. Okay, this is from my side. I can say we are looking forward, and we are very optimistic that we will have some satellite reception in the car in the near future. Thank you very much.